All right, welcome to Robolink. Thank you guys for being here. So excited to have you.
Great. Thank you, Lauren. All right, so thank you everybody for joining us today. My name is Ashleen, joined by my colleague Frankie here. If you have any questions, please feel free to put it in the chat. We'll try to get through this as decent as possible so that we can leave room for more questions and examples. So today what we're going to do is we're going to go through the sensor-powered missions. Here is our agenda for today. Our goal is to focus on the new blocks that have come out, the new platform that we have launched, new looking platform that we have launched. And then we're also going to do some examples of how these sensors work and how you can start using them and applying them. These sensors can be used during the aerial drone competition, so kind of give you some insight as how you could actually use that and the ways that they can help you. So moving forward, we have 7 different sensors, let me get out of the way here, for you to utilize on this drone. When the students first go into the sensors, the main sensor they will probably start with is that color sensor, and then they'll start to move into that front range, bottom range sensor, even the optical flow sensor, which we'll show a little later inside of the new blocks. So first things first, where are the sensors on your drones? So with your drone, you actually are able to see all of the sensors on your drone here. So if I go ahead and kind of put my drone up right there, that right here is our front range sensor. And then if you flip the drone upside down and we go just a little closer, what we're going to see here, actually I kind of go over right here, this is going to be your bottom range sensor. Zoom in just a little more here. So this right here, that is your bottom range sensor. This is going to be your optical flow sensor. These two white ones are going to be your front and rear color sensor. So that's going to be that there. So when you have your sensors working on your drone, you will probably most likely see them on the sensor dashboard. So there is a new sensor dashboard that we have where if you plug in your drone and you connect it to our dashboard, if you move your drone around, you will actively see all the inputs there. And we'll look a little bit more at that dashboard moving on. So first things first, let's go ahead and dive into those range sensors. So for the range sensor, I'll go ahead and move myself to the bottom. The first thing to know about these range sensors, that is going to be your front and your bottom height sensor. That is going to allow you to see obstacles and see distance. Note that this is only able to see up to 1.5 meters. So if it's past 1.5 meters, you're probably going to get like an out of range. You'll see 999, stuff like that. As you get closer, then you'll start to see those numbers populate within either the sensor dashboard, or if you're using a print statement, you can see those numbers start to populate from there. The way that this sensor works, it is an IR beam light. It is not sent out in certain intervals. It is sent out randomly. So if you run one program and you get a list of sensors outputs and you run that same program again, you're most likely going to get some sort of variation of that list that you had before just because it's random. IR can also get reflected weird, or it can also go through like mesh materials. So make sure, as you kind of see in this example, use something solid enough so that it can actually bounce back and forth and you won't have it going through. This is going to just show you the functionality and the blocks that you can use, as well as the Python script that you can use to call the front and bottom range sensor. Note that you are able to change the units of measure from centimeters, millimeters, meters, inches, stuff like that. This is the range, 0 to 200. This is all in units of centimeters. So if you see something constantly repeating 200 when you are trying to showcase your sensor, 200 means it is out of range. If you try to put the drone to something closer, those numbers are going to populate. Do also know that your sensor is recessed into the drone. So if you put your hand right up to the drone itself, it's still going to detect a small amount of distance between it. So you're not going to hit exactly 0. And I don't recommend that you try to push on the sensor either. So let's not do any damage to that. So that's going to be a good way that you will call these sensors. One thing to note that is always something that I try to get people to pay attention to is when you have your drone and you are trying to use the sensors with it, especially the front range sensor, your drone can only see what is directly in front of this sensor here. So as you can see, the drone is wider than what that sensor range is going to point at. So if I have it pointing in a straight line, imagine it's just going to be one thin straight line pointing here. If you are trying to detect something and it does not see it, you probably will see that it shows something clear, and then if you try to fly, your drone's going to hit it. So don't try to use something super thin. Like trying to detect that's probably going to be impossible. You might see it once or twice, but drone has variability. Make sure you have a big enough flat wall so that when you try to go and you move, the students will be able to actually get past that obstacle and not kind of clip it weird. So when it comes to using your bottom range or front range sensor, you might run into some issues where it's not doing well, it's not reading it, something is going wrong with the surface, it's timing out. This is all going to apply to it. So you really want to make sure that when you're using the front range sensor, use something big enough, use something flat. Don't really use like curved surfaces, especially when you are using the bottom range sensor. Curved surfaces, stuff like that might be hard for it to detect. Again, solid material, so meshes, IR beam can go through mesh material, so do make sure solid enough surface so that you can see it. Then also sensor timeouts. If you have the sensor going in a loop to infinity, you will have those prints for as long as that continues. If it breaks out of the loop or if something freezes in the loop, try to add wait times inside of it so that it's constantly able to reproduce those outputs and it doesn't just kind of skip and then skip indefinitely and then the code kind of breaks. So it's good to use those time slots as well too. Oh, programming mats. This is going to be something that's going to be very helpful, especially if you are going to be utilizing the sensors or even if you're not within the aerial drone competition. The reason those mats are there is because they were specifically designed by Robolink to allow the bottom range sensor and the optical flow sensor maintain its stability and control. When you go to competitions, you cannot ensure what kind of flooring they are going to have, but you can ensure the flooring for the program because you will have those programming mats. Those are used to assist the drone. If you fly off of those mats, your drone will still work, but you might just see a little bit more variability with like the drifting, or you might see some height differences. That's just because it can't see the floor, and we'll talk a little bit more. So those mats are going to be your best friends, especially when you start to move into the sensors. So this is going to be an example, something that you will see here. All of these examples can be pulled from our docs page inside of Blockly. So if we kind of scoot over to Blockly right now, this is what you will see. So if you were at the presentation the other day, Frankie talked about we have new blocks and we have kind of a new look. This is our new look. This is also going to be important. So in September, we are going to be getting rid of the junior and the senior blocks. That's going to be these ones up here. Once we release that, basically what we're going to do is these are just going to be combined. So you'll still have all these blocks here, and then the senior blocks will just fall into there as well too. So as for the examples, we're not going to do any flight examples, but I will show you where to get to them. So if you go into this bottom right-hand corner here where it says documentation, you will be able to see all of these blocks that are located inside of Blockly. If we go to senior, let's just quickly go to sensors here. It's going to give you some more information. Just a heads up too, I just posted a help doc that talks about Codrone EDU sensors and their limitations. So this is just going to be another bullet point in depth of everything in this presentation, which you will have, but if you also wanted to see it on help docs, we have it there too. So when you are there, let me go ahead and move my face, then you can scroll down and we have these open in Blockly. So that's what those examples are referring to. So you can open in Blockly, hit continue, and then boom, your code is right there. You can press play and kind of test those out. Really recommend that the students kind of test this because then the more that they see how it works, and they also get to see what it takes to build a sensor. All of our blocks are color coded. So if they wanted to know what blocks are associated with this, you can see you have variables, flight events, you even have these flight sequences, flight variables here, and then you have repeat loops and stuff like that. Very good way to kind of get them engaged and going. All right, so moving on, first things first is the color sensor. So this is most likely going to be the things that students get into the most, and it is part of the aerial drone competition. So this is super easy to utilize, and the students can literally do it in like 2 steps. So the first thing, the way that the color sensor works is you have 2 color sensors, which we saw when we first were looking at the drone. That's going to be that front and that rear color sensor on your drone there. Those emit RGB lights, and those get reflected back into the drone so that it knows to detect those colors. They can be mapped to a particular color. So what that means is you are able to generate your own type of color code. So if you wanted to take a sample of like the table, or if you wanted to take a sample of the floor or something like that, you could generate your own color and then it will be stored as that. And we will show you how to do that in a second. First thing to note too also is your drone cannot, or your drone's color sensor cannot work if it is not on a flat, stable surface and it's not moving. So if you put your drone down and for some reason it's like vibrating or shaking around, it's going to turn the color sensor off. And you can also do it when it's flying. So the goal is you will land on a surface, or if you're not even flying and you just have your color cards here, you put the drone on top of the color card. It will then, you'll see the lights turn on, you'll see it reflect, and then your drone will print in the code what color it detects if you're asking for it, or you can go on your controller and you can see it within the screen. So do make sure it's on a flat, stable surface and there's no movement so that that color sensor can actually enact. And that's what that looks like when it is on the surface and it moves and the sensors are going off. Let me know if I'm going too quick, by the way. Okay, so you have pre-programmed colors inside of your drone that follow the color cards that come inside of your kit, and that's going to be those 8 color cards here. When you are inside of Blockly, there are 2 different colors that you could use for blocks. There is inside of the sensors, there is the colors, which let me go ahead and show that to you right here. Go ahead and get rid of this. So if we go inside of Senior and we go inside of Sensors and we scroll all the way down, you will see this Get Color. There is a difference between this Get Color and then going over here, going to the Color tool and creating a color. Anytime that you see orange colors, you are accessing the default colors. So that is this. So if you try to put your drone on something that's like fuchsia, it's probably going to detect it as red. And it's going to always detect it because it's going to default to whatever color it's finding that's going to be closest to what is already stored. If you would like the drone to detect fuchsia, that is where you would build your own color set, which we'll cover in a second. So just know, if you build your own color set and you collect color samples and everything like that, don't use the orange blocks because that's not associated to your color set. That is the default color. So at the orange blocks, I'll make this bigger for you. This is what you can do with the orange blocks. Not going to focus too hard on these. This is, again, you'll have all this information. It's in our docs page of how this works, but this is how you will call the sensor and the different things you can do with it. You can see the hue, the saturation, the value, stuff like that. All right, so adding a color set. So again, let's go ahead and go back to our reference. So we have something fuchsia, and we want it to be able, the drone, to detect the fuchsia color. This is where you collect your color samples. This is also where you should be collecting your color samples if you are using the color sensor within the aerial drone competition. So like those mats, do not use your color cards when you do that, because that is where it's, again, it's not the same color as the mat, or it's close to it. If you are detecting the surface, or you need to detect the surface of something, collect samples of that specific surface. Just so you have good collection data, the drone doesn't have to second guess, it doesn't have to guess where it goes. You actually are able to have it detect the surface of it because you took the samples. So make sure whatever you want to read, that is what you take samples of. Your color cards are a good way to kind of just get used to it and kind of practice with it, but don't rely on these specifically to fulfill your new color set. Always use that. So if you wanted to do the color set, we'll go ahead and do this together. Inside of Blockly, you will see this new color tool, and it is underneath the console. When you click on here, you can either upload a color set or you can add a new color set. We'll just go ahead and click add. I'll get my face out of the way and we'll click new. It's going to warn you it's going to clear everything. Just make sure you have nothing there that you care about, and then you can click continue. Oh, just kidding. I need to turn on my drone and connect. First connect your drone and then you can do it. So once you have your drone connected, perfect, I can click new color data, and now it's going to ask me to name my color set. I really recommend name it the colors you are using, because if you just name it test and you don't remember what colors were in it, it's going to be a little bit difficult. So we can just do RGBP. Cool. Now it's gonna ask you to do your color. Let me go ahead and zoom in a little bit more here. So it's gonna ask you to add a color. This is where you add a color. Click this, give it a name. We'll go ahead and name this one light blue. And then you're going to, once you've named it, click on this again. Now it's going to tell you that it needs to collect samples. Using your color card, now you will take your color card here. Let me go ahead and zoom out a little bit more so you can see. I have my color card here. Take my drone, make sure you put it on the card itself, and then you can collect samples. Great, it says samples have been collected, and you'll see the light over here. If you collect something too similar to each other, even though they're different and it shows like the same colors, that's totally fine. It's still gonna be able to detect it. So let's go ahead and continue moving. So let's go ahead and do blue. I didn't even follow this RGB, but we're having fun. So there we go. Here's red. So red, add color, red, collect samples, collect. Great. And you can just continue doing it like that. So let's go ahead and add in that weird like fuchsia or table or something. So unfortunately my table's white, but I'm going to call it table. And then I'm going to collect here, move this out of the way, put this directly on my table, click collect. Great, and now it's there. So what you are then going to do is you're going to test that this worked. So we have our light blue and our red color card. We're going to put that here. And then we're going to test color data. As you can see, it says able. I don't know why. Okay, the T's gone. Should say table. We can actually rename that, but it'll be table. And then if I move it to red, saying red. If I move it to light blue, saying light blue. This is what you should be doing with those mats for the ADC or for any material that you're using. If you want it to actually read whatever you name it, you have to use the color sample here. Once I have this and I like it and it's okay, I can click finish and create blocks. If you make a mistake and you do, let's say you take a color sample or you need to recollect it, you can. If you take a color sample, I'll just name this B. And let's say I intended this, actually, let me do this. Let's say I intended this to be green. Take a sample, collect samples, and then, oh shoot, it's on red. Not what I'm supposed to be doing. Your drone doesn't know that. So if you mess up on the samples, you have to make sure that you correct that. What you can do is you can retake the sample, you can recollect it, and then, or sorry, you have to delete it. You have to first delete it, redo it, and then take the sample, and then you will be able to continue from that. If you just click recollect samples, as you saw, it's going to take whatever it took. So you can delete it, or what you can do is, if I am able to get the card, I'll just go back here and then collect samples. And then if I wanted to change it, I could go to this, recollect, and then it will change it. So it's not going to add on. That's something that is new. So before, when you had the color samples, you were able to select how many samples you wanted. Originally, it would start with 10, and then you'd collect 10 of each sample. This is no longer requiring you to put in the sample size. We have already made that sample size. So when you click collect, you're not adding on. So if I click collect 3 times, I just didn't take 30 samples. I just took 10 new samples. It's not at 10. I think we're taking like 50 something. The more samples, the better. So you don't have to worry about the sample size. You just need to make sure that you're collecting what you need to collect, and then constantly recollecting samples is not going to do anything for you anymore. You just collect it once, make sure it's the right sample, then you're all good to go. So from here, if I need to delete this, you can, and then you can add I believe up to 12 different colors. So that is something you can do. You can test, and then you can finish and create blocks, or you can download. This is where a lot of people get confused. If you download the set, you are downloading the colors that you used. That is why it is very helpful to know which colors that you had. So RGB, whatever. Once you have it downloaded, that allows you to build a code, save that code, and when you come back to that code, if you wanted to use the color sensor, you have to re-upload those colors back. So let's go ahead and take a step back first. So let's go ahead and say finish these colors. Here's the difference. You have this load data set, you have these colors here, so this is where your color data is going to live. This is going to be where you need to make sure you're pulling the correct one. So if you made your own colors, always use green. Green is for new colors that you calibrated. If you use the orange blocks, it's defaulting to these color cards. So make sure you have that. The other thing to know is when you create these color sets, you are going to have to load the color data. What that does is it's telling the Python script in the back to pull from a specific file that you had these color sets downloaded to, and it's going to do that. If you try to load a different data set from a different file that you created, it's not going to let you. It's going to have a warning sign. It's going to say the console in here. It's going to produce a warning saying it cannot find it or it cannot run it, and that's just because it's not the same. So that's going to be something that's very important too. If you ever want to use these, let's say if you wanted to do a quick loop here. So if you wanted to say if my color sensor is equal to the color that I predict here, I will then have the drone change to light blue. And then you can even have it print, stuff like that. And then you can do else if. Okay. I will also say this too. I see this a lot inside of students' codes. They don't know this is here or they're unsure how to use it. When you do if blocks here, I see a lot of the times the students will just constantly drag out different if blocks like this. It technically works, but it slows down your code and it makes the color coordination or color sensing very difficult. And that's where a lot of the students see like it's not detecting it the right color or it only detects it once and it's not detecting right again. It's just because the syntax that you're using is not the greatest and you're causing different loops, which is causing different series. So don't pull out multiple if statements, do the else if button here. And that is going to help streamline your code because it is now going to say this and then this and then this and then go to the next block. So then you can do the same thing. So you can say else if this is duplicate to here, do that. And then instead of light blue, you're going to go back to your colors and then you're going to do red. And then you'll do the same thing. Have it turn red. And then you can just continue on your code from there. This is where this needs to come in. So anytime that you are using your color sensor, this has to be attached to your code so that it actually calls it correctly. And then you can do it. So let's go ahead and see. So this is on green. None of this is on green. So let's use a card that I actually have. It's already on blue. Let me go to red. And then if I press play, then you should see the code. Oop, successfully loaded. Great. And then you can't really see it, but my light turned red. And then you can even do that here. Another way that I would recommend, sometimes if the students aren't seeing the LED change or anything like that, it's always good to use a print statement. So you could always just say console print red. Same thing too. So here you go. And then it will print out red and stuff like that. Oh, haha. See? Knowing where your code is also is very helpful. So that's why I didn't do it. And then print red. There we go. Cool. Everyone makes mistakes. Knowing where your codes are, that's going to be very helpful. This is going to be how you produce those colors here. So once you have that, let's go ahead and go back here. We already went through this, just kind of more steps. So do that, go through, downloading it. This is going to be what those blocks look like. I'll make it bigger for you here. This is going to be, you can use the front or you can use the back. Fun note, you can use front and back to detect the colors at the same time. So if you did have something like this, and your drone was perfectly in half like this, in your code, you would just have to specify predict front color and then predict rear color and print those. And then it would say blue-red or light blue-red or whatever you called it. So that is possible. Competition-wise, don't think that's necessary, so stick with one color. In the block itself, you can use front or rear. Either one works. I just normally leave it default to front. If your entire drone is on the color itself, it doesn't really matter front or rear unless you're trying to do some cool thing like that. So doesn't matter how you do it. And then again, just really specifying green blocks is for custom data only. So for loading your data, so as we saw, we downloaded it and then we loaded it. We can load it back up. The way that that works is you will save your XML code and you will save your color code. When you come back, all you have to do is re-upload it, but you need to make sure that your name matches the same name of your code, your data same name of your code. So what that means is when you go to save your code as like we had here, so if I pull this back out and I save this code, that name has to match. So if I click this, file, save, download, this is the name that matters. So then you would just name it, you could just do the same thing, RGBP, and then download. And then you have them both here. Same thing with this. So in this zip file, all of your colors are saved. So if you rename this zip file for any reason and you try to upload it and it does not match this load data color set, it's not going to work. So if we go ahead and we just kind of do an example of this, this is going to be menu, click, open, continue, everything that I just downloaded. So I downloaded this, click open, code is here. And then I can go to the color tool. Let's pretend that that's not there. I can upload a color data. It's going to warn me it's going to clear it. So make sure you save this if you didn't. And then you're going to upload color data. And then you will have to unzip this file. That's something I did miss. So you will have to go in through here, unzip this file, and then when you unzip the file, it will allow you to upload it from here. And then it should be just in your downloads. I can't ask questions, so we'll cover that in the end if you have any questions. All right. So for troubleshooting, some things to note is that sometimes your colors can get a little wonky and it cannot find it all at the same time. If that's the case and you're thinking that it's just not working, you can calibrate the color sensor. The way that you will calibrate it is we have a lesson on this, especially in the JRTC edition. You will go to lesson 0.6 and that will show you how to calibrate it. You will line up your color cards exactly as you see here. So following the order, white, black, red, blah, 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 and continue on. From here, this is where you are going to do that 5-button push. So if some teachers are aware, there is 2 different kind of things that you will use with this action button. When it comes to the action button, there's the 4-button push, which is the calibration. And then there is the 5-button push, which is the color calibration. The 4-button push is the gyroscope calibration. 5 is color. So back to here. If you go ahead and you push the 5 button, 1, 2, 3, 4, 5. You probably couldn't hear it, but it made a nice little chime. And what that's doing is it's telling you it's ready to collect the color sample. From there, you will put it on it and their LED will change to the color that it's supposed to be. So, wow, well, I lost that. My bad, flung the battery out. So if I go back into here and then I am able to change the LED, 1, 2, 3, 4, 5. Perfect. So now it's telling me to calibrate the white on the white color card. I will hit this once, and now I'm going to black, and I will hit this once, and now I'm going to red. And you will continue throughout the whole cycle, following everything that this is telling you. So you can line up your cards, you can tell, the drone will tell you which ones to calibrate to. And then once you have that, you will be able to have it calibrated. This is where you can go into your sensor dashboard, or you can even go onto your controller to make sure that it is reading the correct colors. You are able to see on your controller by going into a specific state. So you will see here, it is going to be, let me go ahead and make this bigger. Oh, there we go. So this is what you will see. It'll say front and rear, it's your HSV. And then if I move it to different colors, you can see it start to change. And then it's going to be the same on the sensor dashboard as well too. So if we go ahead and go back here to the sensor dashboard, you can see that it is able to detect these colors as well. Note, again, these are the custom colors. So if you make, or sorry, blah, blah, blah. These are the standard colors. So if you make a custom color, it is not going to show in your sensor dashboard. It will only go to the default 8 colors that you have. So don't expect like fuchsia to pop up here. It's most likely just going to show up as red. All right. So moving on, we have the gyroscope and accelerometer. So your gyroscope is what helps maintain its stability when it is actively flying. And you will see that this is going to be the general axis of how your drone moves. So pitch is along the x-axis, roll y-axis, throttle z-axis. Again, not really going to do too much on this or dwell too much on this. This is just the function documentation of how you can use it and how you can call it and the different degrees and everything. This is the function for the for the accelerometer. So this was the gyroscope that you could call. This is the functionality for the acceleration here. You can reset your drone with the reset gyro. You can reset it using that function. It normally resets anytime the drone takes off or powers on. But again, if you're having that weird kind of drifting issue or it's just kind of going a little wonky, that's what that 4-button push is going to be on the action button at the top of your drone. Just make sure when you do that, you don't have it tilted or anything. I think we'll cover a little bit more on that later. Right now. So this is going to be what it is. So you might run into the issue, I'll get out of the way, where if your drone is drifting, you're trying to trim it, it's not working, and it's just kind of making you have a really bad headache. Most likely what it is that the drone either took a really hard crash, it's kind of off kilter. You can write that just with that 4-button push. The thing to note though, if you do the 4-button push, you should hear a chime. It'll be like a little doo 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 doo. If it does not do that, do not automatically try to push it again. You're gonna probably put it into the weird like color calibration state, or it's just gonna get a little wonky. What you should do is just turn the drone off, turn it back on, put it down flat on a surface, let it do its thing, and then push it 4 times again. Lots of the times there have students where be like, it didn't work when I pushed it 4 buttons, but it worked when I pushed 5. And I was like, that's great. You're calibrating the color sensor. It's not doing what you think it's doing. So only 4-button push in rapid succession. Don't do it like 1, 2, 3, like 4-button rapid succession. You'll be able to do that. This is where you'll have more balance, you'll have more stability, and it should be able to right itself. Also, make sure you reset your trim values back to 0. So just reset your trim values back to 0, do the calibration, and you're all good to go. This is, again, going to be just an example of what you can do with this gyroscope. You can find these in the docs page. The biggest thing when it comes to these that students utilize or need to make sure that they utilize is that they're correctly calling what they are looking for. So as you can see here, we have a move to change the yaw. Yaw is not roll. Yaw is the drone turning like this. So it is turning about the z-axis, since that is the z-axis here. I've seen lots of times where students will be like, oh yeah, once it changes to 90, then it will stop, but then they're affecting the roll or they're affecting the pitch. Your drone's not turning, it's doing this, which is still facing the same direction. So just make sure that the sensors that you're trying to use, the commands that you're using for it actually apply to it. Otherwise, it's going to go into that weird infinite loop, but they're like, this is not working. I can't get it to do this. It's just because you're calling the wrong thing, or you're just not using something that actually hinders or actually will break it out of the loop. Just something simple. All right. This is another example. If we go into our sensor dashboard, as we saw here, you can see that when you actively move the drone, you are actively seeing the sensors do it. This is a great way for students to kind of get more involved and start to understand what different directions and what different movements actually affect. So pitch, you can see it's going forward, tilting front and back. Yaw, that is the rotation of it, not moving. And then you will also be able to see the roll, how it's bending back and forth. So I like to play a little fun game with my students where I'll be like, okay, try to get the roll to like 50. And then they'll have to see there and they're like, oh, I got it. Ha, got it. And I was like, great, you got it to 50 or close to 50, but that's negative 50. Try to get to positive 50. And then that's another way to help them kind of understand the difference between them. All right, so this is going to be a fun one. So for the optical flow sensor, so when it comes to using the optical flow sensor, your drone initializes coordinates that allow the drone to take off in a measured increment. Please note that when you use the optical flow sensor and when you use the bottom height sensor, you have to be 1.5 meters or below. If you get higher than that 1.5 meters, there is a range, and that is where you're going to see more of that instability. You're going to see some drifting. You're going to see some different variations within that z-axis. And that's just because the drone literally can't see the ground or can barely see it, and it turned into a blind person and it's trying to get a little bit closer. That is it. That is nothing to do with like the sensor malfunctioning or anything like that. It's just you are too far away. So keep it lower. Again, that's where those mats are going to be your best friend. So this is how you're going to use it. You can call it using the centimeters. You can use meters, inches, stuff like that. Don't really think anybody uses meters or millimeters, but you definitely can still. And this is going to be the main issue that we see is that when you try to use the optical flow sensor, you're flying over like a shiny surface, or you're not flying over any textured or patterned surfaces. And what you'll see is like the drone will fly and then it'll like jerk and then it'll come back. That jerky movement is because the sensor just lost itself. Even if you are well below that 1.5 meter height and you still see that jerking, it's just because of the surface underneath it. If you have the ability to have the mat, or if you have the aerial drone competition mat, or even the Robolink mat, if you have those there, you're not going to see those. And then you're going to have way more control. So if you don't have the mat, doesn't mean that you completely lose out. Just make sure you have textured patterns on, like if you have a carpet or anything like that, that's totally fine. Hardwood's fine too. Just to count that those could happen. So it's not that it's broken, it's just something that will happen with it. And then fly over a consistent surface too. This is a call out that says you can disable your optical flow sensor. What that does is your drone will just drift, like nothing's keeping it safe or keeping it there. Highly recommend that you don't do that, especially when in programming. It's totally fine if you wanted to do that if you are manual piloting, but you have to be very persistent with putting in those small commands. So this is more similar to like real drone, like FPV command, where every slight thing that happens to the drone, you have to correct for it. Turning that off turns off that auto correction. So if you're programming, don't change the flight mode, just leave it the way it is. Just help it by helping it either change the surface or adding in that textured surface. All right, so new functions. So the cool thing that we have now is you can use the optical flow sensor without actually having to call the sensor. So before, if we go back into Blockly here, we would only be able to move in seconds. So we have something like this, where we would go forward for 1 second at 50% power and stuff like that. That is now possible, or this is still there, but now we can actually move measured increments by using this block here. Oops. So now we can go forward for 50 centimeters and stuff like that. Before, the only way to move like this was by actually calling the sensors, and then you would have to get the position and then change the position based off of where the drone is. Makes it a lot easier now that you don't have to do that. So this is a great way for students to kind of already get involved with the optical flow sensor and also just help you increase your accuracy. You have the field measurements. You have how far away something is on the field. Use this to your advantage. No more guessing how many seconds, no more guessing how many percent power, if it fluctuates. Your sensors are there to help you, and those mats are especially there to help you. So if you can kind of hone in and you can go like, hey, I can get exactly 50 centimeters away from this hoop that I need to be, and then all I have to do is increase in height. Perfect. Much better than being like, I think it's 3 seconds away, and then I'm going to try to do this at 25% power. Code is your own. Do what you want. If you want to make it difficult, be my guest. Or you can do however works for you. But this is going to be extremely helpful. Same thing with if you were in the call the other day too, Shelly kind of pointed out like those decorations on the hoops. Yes, they're slight decorations, but they're actually there for the sensors. So that is a big enough board that you can use the front range sensor to actually detect it. And if you have the field, just pull out your sensor dashboard. Have your drone move. You can see the front range sensor here. You can see the bottom range sensor here. Have the students fly the drone, walk the drone through, and see if you can see the sensors and kind of build a code off of that. It's going to really help with the stability of it. And again, kind of take away that guessing portion. So I'll cut back here. So you can fly a certain distance. It does work best over the programming mat. Does not mean it will not work, though. It just works best. And then you will have an origin at 0, 0. So that is something to note when you are using the optical flow sensor. Every time you take off, it resets to 0, 0. So if you try to take off, go forward, take off, go forward, it will reset. So here's an example of how you could use it. You could go forward, turn right, go forward, and you can create this cool little Z example. All right, going a little bit more quicker now. So with the barometer, you have the ability, it is a chip inside. It actually reads the outside barometric pressure when you have it, and it reads it by pascals in default. Again, here's how you can call it. Different elevation you can call it in, and then the pascals or millibar. Cool. So if you have any questions, please, please, please visit our base camp. We go over all of the sensors in the advanced portion of our lessons, and you can find that here for both Blockly and for Python. And we are also here to support. Cool. Questions?
That was amazing. Every time I listen to you guys talk, I learn something new. And I'm just blown away at how dedicated Robolink is to helping our community with their drone. So I thank you for being here.
Yeah, thank you for having us.
All right,
You're
I am going to stop the recording and then we can do questions and answers. So thank you guys for being here.